Welcome to ScienceCover.com. In this session, we will look at density. We'll focus on what we mean by density, using the density equation, how we could rearrange that equation, and how we could measure the density experimentally. First, pause the video and complete the Do Now task. Let's check the answers to the Do Now task. Let's start by looking at what we mean when we talk about density. Density is the amount of substance within a certain volume. So we can think about it as the amount of material in a certain space. So the two diagrams in front of us show a high density, where we've got a lot of material in a small space, or a low density, where we've got not very much material in a small space. But density is the amount of substance within a certain volume, so we should be looking in 3 dimensions, not 2. So these two diagrams show us a 3-dimensional space, and we can see in the high density we have a lot of material, a lot of substance within that 3-dimensional space, and in the diagram on the right there's not as much material in that 3-dimensional space, and so we would say that's a low density. We can calculate the density mathematically using the equation density is the mass divided by the volume. And since mass is measured in kilograms and volume is measured in meters cubed, then the unit for density becomes kilograms per meter cubed. We can also place the density equation into an equation triangle. We'll use the Greek symbol rho to represent density and place it in the bottom left of the triangle. And then this gives us the mass on the top triangle divided by the volume, which will be on the bottom of the triangle. If I want to find the mass, then I can cover up the mass, and it tells me that the mass is the density multiplied by the volume. If I want to find the density, I cover up the density, and this leaves me the mass divided by the volume. If I want to find the volume, then I can cover up the volume, and that tells me that it's the mass divided by the density. So I can rearrange the equation 3 ways to calculate mass, density, or volume. Now pause the video and complete task 1. Let's check our answers to task 1. Density is a measure of the amount of mass per unit volume. We measure density in kilograms per meter cubed. A dense object has a large amount of material close together, whereas a less dense object has a small amount of material spread far apart. So the missing words here are mass, kilograms per meter cubed, large, and less. Question 2, complete the equation. Density equals the mass divided by the volume. Now let's focus on the density equation and how we can calculate the density. Example 1. Calculate the density of 450 kilograms of seed that is stored in an 80 meter cubed barn. Well, first, to calculate the density, we need to take the mass and divide it by the volume. Now I can substitute in the values I'm given in the question. Mass is 450 and the volume is 80 meters cubed. 440 divided by 80 is 5.5, and the unit for density is kilogram meters cubed. Example 2. Calculate the density of 1.5 kilograms of hydrogen inside a 0.3 meter cube tank. First, we place the equation. Density is the mass divided by the volume. Then substitute in the two numbers that were given in the question. So mass is 1.5 kilograms and volume is 0.3 meters cubed. The 1.5 divided by 0.3 gives me 5. So the density is 5 kilograms per meter cubed. Now pause the video and complete task 2. Let's check the answers to task 2. The paste is made by compressing 1 kilogram of tomatoes into a 0.2 meters cubed container. What is the density of the paste? Density is mass divided by volume, so that's 1 divided by 0.2, which equals 5 kilograms per meter cubed. 5 kilograms of potatoes are stored in a sack with a volume of 0.5 meters cubed. Calculate the density of the potatoes in the sack. So again, density is mass divided by volume, so it's 5 divided by 0.5, which equals 10 kilograms per meter cubed. 5 50-kilogram dogs stand in a field of 100 meters cubed. What is the density of dogs in the field? So the density is mass divided by volume, so that's 50 divided by 100 gives us 0.5 kilograms per meter cubed. Question 4. What is the average density of a human being if the average person has a mass of 62 kilograms and an average volume of 0.062 meters cubed? Well, the density is the mass divided by the volume, so that's 62 divided by 0.062, so that's 1000 kilograms per meter cubed. A circular child paddling pool is 0.5 meters tall and has a radius of 1 meter. If the water in the pool has a mass of 1566 kilograms when it is full, calculate the density of the water. So the density is the mass divided by the volume. Now to get the mass in this case, we've got the 1566 kilograms, but to find the volume, we have to do the area of the pool, which is pi r squared, so that's pi multiplied by 1 squared. And then we've got to multiply that by 0.5 because that's the height of the pool. So the volume is 0.5 times pi times 1 squared. So if we put this into the equation, then we get 997 kilograms per meter cubed. Now let's rearrange the equation and see if we can calculate some other values. Calculate the mass of water in a 30 meter cubed pond if the density of the water is 997 kilograms per meter cubed. So we want mass, so that means we need to get the density and multiply it by the volume. So the density we're given is 997, and the water takes up 30 meters cubed. So if we multiply these together, we get 29,910 kilograms. What is the volume of space taken up by 600,000 kilograms of water flowing in a tributary if the density of the water is 997 kilograms per meter cubed? So this time we want volume. So if we cover that, we see that it's mass divided by the density. So the mass of the water is 600,000 and the density of the water is 997. So this means that the volume that the water takes up is 601.8 meters cubed. Now pause the video and complete task 3. Let's check our answers to task 3. Number 1. Calculate the volume taken up by 1,000 kilograms of hydrogen gas if the density is 20 kilograms per meter cubed. So the volume is the mass divided by the density. So that's 1,000 divided by 20, which gives us 50 meters cubed. A car is crushed in a scrapyard into a cube of 0.9 meters cubed. The density is 330 kilograms per meter cubed. Calculate the mass. So the mass is the volume times the density. That's 0.9 times by 330, which gives us 297. A swimming pool has dimensions 5 by 10 by 3, and the density of the water is 997. Calculate the volume of the pool. Well, we do 5 times 10 times 3, so that's 50 times 3, so that's 150 meters cubed. Calculate the mass of the water in the pool. Well, to find the mass, I've got to do volume times density. The volume I've just worked out as 150, and the density is given to me as 997. So 150 times 997 gives me 149,550 kilograms. The circular swimming pool has a height of 3 meters and a radius of 5 meters. Calculate the volume of the swimming pool. Well, first I need to find the area of the swimming pool, which I can do by using pi r squared. So pi times the radius squared is pi times 5 squared, which gives me 78.5 meters cubed. Now to find the volume, I've got to multiply that area by the height. So 78.5 multiplied by 3. That gives me 235.61 meters cubed. Calculate the mass of water that the circular pool can hold. Well, to find the mass, I can use that volume and multiply it by the density. Now the density of water is 997, so I can multiply 235.61 by 997, and it gives me 234,912 kilograms. Does this pool hold more or less water than the pool in question 3? Well, it holds more water, as obviously 234,912 is larger than 149,550 kilograms. Let's look at how we can measure the density experimentally. A regular shaped object is an object that we can take measurements of easily, and that those measurements don't change from one side of the object to the other. So for instance, with a cube, we could measure the length, the height, and the width. And we could measure it at different points, and they should have the same heights, they should have the same widths. This is what we call a regular shaped object. So to measure the density of a regular shaped object, you can just measure the length, the width, the height, and multiply these together to get the volume. You can find the mass by placing the cube in a scale, and then we can calculate the density by taking the mass that we've worked out, taking the volume that we've worked out, and dividing the mass by the volume. However, for an irregular shaped object, such as a plastic bath duck, the height changes over the course of the object, as does the width of the object, and as does the depth of the object. This makes it incredibly difficult to work out the volume. So we have developed a technique to help us find the volume easily. Fill a measuring cylinder with water and take a measurement for the level of that water. Then you submerge the shape, such as the duck, below the level of the waterline. Now this pushes the level of the waterline higher, and we can take a measurement for the new level of the waterline. Now the difference between the original level of the waterline and the new level of the waterline tells us the volume of space taken up by the duck. Using this process, we can find the volume of the irregular object. We can find the mass of the irregular object in the same way by placing it on our scales, and then we can calculate the density simply by taking the mass that we have and dividing it by the volume that we found. Pause the video and complete task 4. Let's check the answers to task 4. First, what equipment will be required to find the density of an irregular object? So we'd have to have the irregular object, we'd need a balance to calculate the mass, a measuring cylinder so that we could find the volume, a pen and paper so that we could record our findings, and a calculator to help us to work out the maths. Question 2. Describe the method to calculate the density of an irregular object. So first we'd have to place the object on a balance and record its mass in kilograms. Secondly, we could place the water into a measuring cylinder and record the water level. Then we place the irregular object into the measuring cylinder and the water level will rise, which means we can now measure the new water level. Step 4, we can calculate the change in water level and work out the volume of the object. Step 5, now we have the volume and the mass, so we can use the density equation to mass divided by volume to find the density.